But before he became a data engineer, he was a full stack engineer. And before he became a full stack engineer, he was a neuroscientist. So Christian takes all of what he's learned from these past roles into his practice of data engineering. And in his spare time, he likes to hang out with his kids and take care of plants that grow in his yard. Maybe you can teach me how to keep care of my plants at home, because I keep killing them. And our third presenters of the night, we will hear from Karin and Will. Sorry about that. Karin and Will, who are from VetSource, who will help us to track down the source of truth in data. Will is the director of data and analytics at VetSource and has spent the last 7 years solving data problems in the vet space. Karin is the manager of analytics at VetSource and has made the switch from financial data to pet data 2 years ago. And tonight we're also adding a different type of content, which is a panel, so we're super excited to test out this new format. And we'll be closing the night off discussing the next 10 years of data. So Gleb will be back up to join us for the panel, and we also have Scott joining us, who is here from Brooklyn. Right back there. Hey, Scott. Scott was an early user of many of the tools that we now consider part of the modern data stack. And Scott is the founder of Brooklyn Data, so he saw the power of doing data right. And however, he noticed that while cloud data tooling is more important and more powerful and accessible than ever, many organizations still struggle to see success in completing their data initiatives. So in 2018, Scott started Brooklyn Data, a consultancy that partners with its clients to build data capabilities that last. Recently, they were acquired by an agency, Feller. Am I saying that right? Villiers, there we go. Scott now holds the title of Chief Data Officer at Villiers. And we wanted to give a huge thank you to all the folks who made this happen tonight. So thank you, big round of applause, thank you. So I'm sure most of you know Datafold has generously sponsored the night for us, so they've provided all of the amazing pizza and drinks that we have, and they helped us to cover the cost of some of the other event logistics. Throwing an event this big is relatively complicated, so thank you very much to everyone, and Gleb for flying in from New York City. Also, a big thank you to 111 for having us here in this amazing space. So it's difficult to find spaces this big for this many people. So thank you to 111. And thank you to Brooklyn Data Co. as well, and Scott for flying in as well. And their team for sending us some swag. I'm not sure, is there any swag left? No, it's all gone. Okay, well, so you lost your chance, everybody. And as of today, we also want to thank the members in the group. We actually surpassed 1,000 members as of this morning, so that's super exciting. So a round of applause for everybody who's So it's been really amazing to see the engagement in the group and growing this community, so thank you everyone for continuing to come back. And on that note, we know how hard it is sometimes to RSVP when some of the events are smaller, so we wanted to change it up and give access to people who are here in the audience first to the next event. So our next event is going to be on June 15th, and we will be at Finance It. So we should have the RSVP available shortly on Meetup, if it's not already yet. By the end of the night it will be, and so if you want to join us on June 15th, you should get first dibs. And with that, I will turn it over, oh, sorry, one more thing. We're going to ask you for feedback at the end, and this time, if you participate, if you would like to enter for an Amazon gift card to win $25 to share your feedback, we will have that as an option. And with that, I will turn things over to Gleb.
Thanks so much, Lindsay. Hi, everyone. Great to be here. I'm a New York Rangers fan, but Rangers aren't going very far this season, so for tonight I'm Maple Leafs fan. That's how you know there are true data fans here. With the game going on, I really appreciate you being here. All right, so we're going to talk about migrations. Hopefully that's an exciting topic, or an exciting conversation about not very exciting topic. I'll skip my intro since Lindsay did a very good one already. I'm going to tell a tale of two migrations. One was not very successful. One was a successful one. I was kind of involved in both. And I'll talk about do's and don'ts for a successful migration, and also what to do once you are on the shiny new stack. So first, what are migrations? By migrations, we mean moving your data workloads from old warehouse to a new warehouse, not like continuously replicating, but actually moving and then turning it off, hopefully, if that's successful migration, or moving from some data registration framework like MicroStrategy or Airflow onto something beautiful and new like dbt. So who in this audience have done migration before? Okay, quite a few veterans. Who is in the midst of migration now? All right. See some hands here, so hopefully that might be helpful if it's not too late. Why talk about migrations? So having done having spent 2.5 years of my life migrating Lyft of legacy warehouse to new, I think that migrations are typically quite complex because by the time you're migrating, you already probably pushed the old system too far. They're not fun because I don't feel like building new stuff, you're just moving things around. They typically go over budget and they never complete on time. And in my case, I believe the migration I started is still going on. So, and it's been seventh year now. So, but migrations are necessary. So the reason why we're doing them is because we outgrown the old system and the business desperately needs to something far more scalable. Okay, so what are the two tails? One tail is from Lyft. I was one of the first data members at Lyft, and I happened to be a poor guy, or like a guy running Lyft's migration from Redshift to Hive. That started in around 2016. I've been there for 2016 to almost 19, and as far as I know, that migration is still finishing up. That is, I would say, my personal failure at this project, so I think I failed. So that was mostly negative don'ts I will take away from the Lyft part. And then Fair is our current customer of Datafold, and we supported them in the migration, and that's a success. Mostly because I think the team at Fair did a much better job about being thoughtful about how to run migration. Not because they chose Datafold, but actually about how to architect and sequence and plan it. So we'll talk about that. And they were supposed to co-present, we were supposed to co-present together, but they are out of town, unfortunately, so I'm here to tell their success story. Hope I'll do a good job. So both migrations are kind of like large scale. So at Lyft, we had about 500 tables in production at the time we started the migration, about 2 petabytes of data in the warehouse, over 200 data users, over 100 dashboards, and over 10,000 various ad hoc reports in the AI tools. So quite a lot of stuff. And then Fair did an even larger scale migration, I believe about 5,000 tables and similar size of data teams. So big projects. Okay, so what are 5 things to think about when I do migration? I think that it's a very complex project, so it's helpful to kind of break it down into different dimensions. So 1, obviously, you have to choose the right tech. 2, how do you architect the migration? How do you approach moving all the workloads? Whether you choose to outsource or do this internally, how do you sequence the steps in this project? And finally, how do you automate as many steps in this as possible? Because obviously there's a lot of work to do. So we'll kind of go into each dimension, and I'll tell you things I did wrong at Lyft, and then things that Fair did very well. Okay, so tech choices. What are things important to consider? Obviously, scalability. So we're moving to a new system for a reason. And by the way, these loosely apply to both migrations between warehouse tech, but also between frameworks. So I'll kind of use the term migration interchangeably for both cases. So scalability, important obviously because we're moving out for a reason. Hopefully we should think about the next 5 years or ideally 10 years because migrations are really expensive, and so it doesn't make sense to do a migration and then do another one in 2 years. User experience, very important. Don't forget to ask the users, are they actually liking the new tech? Will they be productive? Is it only for the data team or for maybe semi-technical people, will they be able to use this technology? Interoperability, so how easy it is to integrate with the new stack. What is the trajectory of the technology that you're choosing? Or maybe you're trying to adopt something which is way too early for your organization. It's shiny and cool, but it's not mature enough for the org of your size. Or maybe it's too late in the cycle and it will be kind of obsolete and legacy in a couple of years. Cost, kind of enough said. And beware the open source trap. I'll talk about this in a moment. So, when we chose Hive, by the way, who here heard about Hive? Okay, so some data old-timers here as well. So, for those of you who don't know, Hive is SQL on top of MapReduce. So MapReduce is what actually moved the big technology behind big data that kind of appeared in the early 2000s, and that had Java interface, which was really hard to work with. And then Hive was an attempt to put a SQL interface on top of MapReduce, which made it a little bit better, but still it was very slow and hard to work with system. And so scalability for us at Gleb was good. Hive was far more scalable than Redshift, primarily because it was a data lake architecture. So in Redshift, at that time especially, had storage coupled with compute. So at some point, we had the biggest cluster, I think, after Amazon running in the universe, and we couldn't really push it further. With Hive, we could scale it because all the data was in S3, and we could throw more hives at it. User experience. So that one we got really wrong. So Hive was really bad. Like, takes 90 seconds to compile SQL and tell you to go to comma, kind of bad. You have 150 parameters you need to tune for the query to run, kind of bad. Like, allocate memory for the map stage and reduce stage. So that didn't really fly with the business users, and we even struggled with data engineers using that tech. Interoperability was good, again, because it was data lake, so it was easy to plug other things that were better than Hive to the data lake. Tech trajectories was the bad, in my opinion, because we adopted it when Hive was kind of at the peak and was coming down in terms of the adoption cycle. Facebook probably was, at the time, the biggest user of Hive, but they were kind of already getting off it to new technologies like PrestaSQL. And by the time we started adopting and actually got Hive to production, no one actually was using it besides us. And cost, we thought would be better than using something like Snowflake or BigQuery or proprietary tech, but it turned out to be far, far more expensive just because you're running an open source technology that was also old and slow. But most important, and probably least obvious one, is the open source trap. So what I mean by that is that a lot of times in an engineering team, you kind of leaning to adopt open source technology as opposed to vendor technology because you don't want to get locked in with a vendor. But the problem is that sometimes it's hard to run open source technology, and you haven't really accounted for all the costs that are associated with it. So it takes a lot of engineers to run an open source data transformation technology like Hive, even Presto, at scale at a large company. And even though we wanted to go for open source, we actually were forced to hire a vendor to host it for us, and we ended up with the same kind of vendor lock-in we wanted to avoid in the first place. So these are kind of hard lessons learned. Fair chose to use Snowflake. And a lot of these problems were solved, and I believe they're quite happy with that vendor. Snowflake didn't pay me to say this, but I think ultimately a lot of these things are solved with the modern data warehousing technologies. BigQuery, Databricks, Delta SQL, even Redshift is actually better these days than it used to be. Okay, architecture. This is a really important one. When you're running migration, you have two choices. One, you lift and shift everything. So you take your workloads, your SQL that runs in the old system, and you try to just port it to the new system with minimal modifications. You know, no matter how ugly it is, no matter how slow it is, no matter how your eyes hurt when you're reading this, endless stored procedure code, that's lift and shift. There is the proper way, which is, this is finally our chance to do this right. Build our star schema, or Snowflake schema, or Datafold, and get this right. Question, what should we do here? Who votes for lift and shift? Who votes for the proper way? Okay, some shy. I see some shy hands. Cool. So what I try to do is the proper way, and that was absolutely the wrong call, because migrations are hard enough at scale to execute if you just do lift and shift. If you try to interject and also do modeling in the process and like gather business requirements and they'll change all the schemas, it turns out into a never-ending project. So I find myself running around different stakeholders and going into meetings with marketing attribution team and try to tell them that the model that they used was very ugly and I had a much better idea, and they didn't believe me. And they were right, because it's impossible to remodel, very hard to remodel all your business while also executing a very expensive migration. So maybe there are cases where proper way is warranted, but I would say that increases the risk of project big time. Outsourcing. If you're doing migration, I would strongly recommend you think about outsourcing it and hiring an awesome consultancy like Brooklyn Data Company, primarily because, one, of the opportunity cost for your team. When your team executes migration, you're not doing anything for your business besides migration. You're not building new models, you're not building new use cases, you're not supporting your business stakeholders, and that has a tremendous opportunity cost because no one else can do this but your team. And also, the awesome data consultancies can do this much more efficiently because they've done it multiple times. One caveat is I wouldn't task consultants with re-architecting a data model. Obviously, that's another mistake I made at Lyft. We hired an outsourcing consultancy and we asked them to model data for us. That was a bit worse than me trying to do this because they have even less business context, and that just slowed down the project even further. So sequencing. So how we actually go about executing migration. So we have this legacy database, and loosely speaking, we have raw data, we have dry data. We have an orchestrator, let's say Airflow. It takes raw data, moves it, transforms it into dry data. And then we have business apps that are reading from here, Looker mode, you name it. So how do we transition it to the new system? The right approach to do this, I believe, in my very strong opinion here, is that the first thing you want to do is to make sure that your business consumes data from the new system, because chances are that you're moving from legacy because it's already overloaded, and it's really hard to sustain business on the old system while you're doing this migration. It can take months. So a simple thing that you can do is set up a continuous replication of data from old system into new. We're talking about your derived models, right? And then you switch over your business apps to consume them from the new system. What this does, one, removes the pressure from the old system. Two, it frees up your hands in that you can do whatever you want here, right? Because if you want to like delete tables, refactor them here, do whatever hygiene you need to do, business doesn't depend on it anymore. And also, very importantly, your business users are starting to familiarize themselves with the new technology, and so when it's actually time to switch the old stuff and move them to the new stuff completely, they already are comfortable. And then obviously, migration is not done until this thing is replaced with this thing, right? Like natively derived data on the new system. So that's how Fair team actually orchestrated it. In Lyft's case, it was far more complicated because we couldn't consume data using Hive, it was too slow. So we had to put Presto on top of it. Presto wasn't stable, so it was a big mess. But loosely speaking, this is the architecture that I would, sequencing mode that I would recommend. Automation. So migrations are slow and very laborious process, especially if you're trying to migrate 5,000 tables. So the more you can automate in that process, the better. The first thing you can automate is you can get smart about planning. So what does planning mean for migration? Ultimately, we all run huge DAGs, and we all have all these dependencies between the tables and the IAPs on those tables. And the first thing that really helps is untangle this using lineage. So if you can, I would recommend leveraging column-level lineage actively to plan your migration. What can lineage tell you? It can tell you, one, what are the dependencies in your data pipeline ecosystem? how does the business consume the data. It can also tell you valuable information such as how important each table, each column, each BI dashboard is. And you can prioritize things based on this. You can maybe decide not to even migrate some of this stuff. And you can sequence what goes first, what goes next, etc. So these days, column level lineage is available in multiple data catalogs like Atlan and Secoda and others. We also provide this as part of our platform. So very, very valuable piece of information. And typically you can consume it from the UI, but as a data engineer, I always found that it's most useful if you can run queries against it so you can actually be smart about deep planning. At Lyft, we use a column level lineage solution called Compiler, so we got acquired by Google and now is part of the Google Cloud platform. The second thing you can automate is query translation, obviously, right? So if you have Teradata SQL or stored procedures or something like that, and you're trying to translate it into Snowflake, you can use tools that help with this translation. So GCP comes with a built-in query transpiler. That's what our friends from CompilerWorks actually provided them. But there's also an open source awesome project called SQL, which is built by, was incubated at Airbnb. And it is a full-blown SQL compiler and transpiler, and it comes with pre-built syntax for multiple most popular SQL dialects. So you can actually use it to do a lot of really smart stuff, such as transpiling SQL from one dialect to another. But if you're really, really, really excited about SQL, you can go as far as automatically optimizing your Snowflake queries. But that's another story. And then validation. So as we were going and migrating and advancing our migration at Lyft, the big challenge we ran into is that the business didn't want to use the new data. We had this table, the most important table at Lyft was called dimension rights, as you can imagine, was about rights. And on the new Hive system, we built fact rights. I thought it would be really smart to name it fact because I thought rights are actually a fact table. But people didn't appreciate me being correct about this, and no one actually wanted to use this table. Why? Well, because one, the data in this table slightly differed from what we had at Redshift, and we couldn't explain that, and we couldn't really tell the business how much it was different. We constantly run into like stakeholders pointing out different inconsistencies, and that made people very, very anxious, and we struggled a lot with getting business sign-off. And obviously, migration is not done until the business is using the new system. So we had to build hundreds and hundreds of lines of Jupyter notebooks with scripts that would compare the data in various dimensions, and it was really hard. So this is what we solved with Datafold. There's a tool, it's open source, it's called DataDiff. DataDiff is like Git diff, but for data. It essentially helps you compare data within warehouse or across warehouses at any scale. And you can use it with different kinds of databases. And if you want to use Datafold, then it provides you the UI for this. So this is what the FAIR team used to accelerate their migration. And the way they did it is by running diff to compare the legacy derived data with the new system derived data. And not only they ran those reports, they hooked it up to Airflow using the API. So every day they would run like 5,000 diffs for every single table that they needed to migrate. And they had a report that said how far off the new system is from the old system. And if anyone asked, any data consumer, finance, whatnot, internally as well, they could tell how close they were with migration. When they got to 100%, they basically turned off the old table, and then the new table became the source of truth. So that's how you can automate the validation piece. And so what does it mean in terms of the success story? So for FAIR, migrated 5,000 tables. They said we helped them accelerate it by 6 months by automating the planning phase and the validation phase. They didn't have any problems with stakeholders. Users were happy. So very, very happy, successful migration story. But again, not only because of Datafold, obviously, but because they went about it in a much smarter way than I did when I was at Lyft. So hopefully we'll learn something here. I'll take one more minute and I'll tell you what happens after you migrated data. Because obviously the story doesn't end there. So now that you migrated data, the question is, how do you ensure data quality going forward? And this is where Datafold comes in. So if you're developing on dbt, you can use the same tool that I just talked about, DataDiff, to help you test as you develop, as you deploy at each stage of your development process to make sure that the code that you are developing continues to be correct. So how does development testing work? Very simply, we made a code change, and we did a dbt run, and then we do datadiff-dbt. This is the open source tool. What this does is it picks up on the changes that you made in development, and it tells you how your data will be different. So it diffs your development environment against production, tells you the high-level output of this. And why is this important? Well, it tells you whether or not your changes are actually correct. This is the CLI output, and you can also plug in the cloud. So we have a free cloud version for individual engineers. If you use cloud, then you would also get a visual report, and then you can go all in on the diff, explore it side by side, and very rich UI like this. So you can see down to individual characters. It's very cool. So it helps you make sure that the code that you are about to ship is actually correct. And then where we actually make money is by helping teams implement all of this in CI. Why this matters is because when DataDiff runs in CI as part of every pull request, then the entire team knows exactly what's happening with data on every change. So as a code reviewer, you get full visibility into the changes. You know exactly what happened to the table which was modified. Are there any BI tools affected? Downstream stuff. Code reviews are faster. No breaking changes. Everyone is happy. Cool. So what can you do with this? You can try open source diff. It's a Python package. It has a Python API and has integrations with most of the popular warehouses, including DuckDB, of course. And you can use it to diff data in all your workflows, regardless of your data stack. And then if you're using dbt, I would encourage you to also try our development testing workflow with Datafold Cloud for free. And if you want to find me anywhere, I'm on dbt Slack and Tools Datafold, gleb@datafold.com, find me on LinkedIn, and happy diffing and happy migrations. Oh, okay, so Jonathan says I can take questions.
How do you measure the cost of migration? How do you measure the cost?
How do we measure the cost of migration?
In advance, right?
The cost of the project itself, or the cost of the new system?
No, cost of the new system based on the order.
Yeah, that's a great question. So the question is, how do we measure the cost of the new system when choosing the tech for migration? So at Lyft, I did it the following way. We knew how many queries we are running, and we also knew the average size of the data scanned by each query and average query runtime. And we used those three inputs to model that against different pricing of different vendors, and also the approximate cost of running it open source. In fact, we didn't do a very good job of modeling the cost of Hive upfront, as I mentioned, so we vastly underestimated. But once we had Hive up and running, and there were conversations on the team of whether we should use something like Snowflake or BigQuery to replace it, we had very good numbers because we knew exactly, the data scanned, the query number of queries and query runtime. And the numbers showed that running on BigQuery with plain pricing, like out-of-the-box pricing without discounts, would be actually 40% cheaper. So that was a big revelation, but we were too deep already in the migration that we decided not to pursue that. But was a very interesting piece of data. But great question. One more question?
So if you're running your data diffs on CI, it sounds great. Like if the model building process takes a really long time, maybe I don't know what DBT is, but could this create like a very long test cycle for my PMs?
Great question. So the answer is, I'll answer two ways. One, DBT is pretty smart these days about how do you build staging environments. They have this feature, Slim CI, which allows you to kind of only build things that you changed and reuse data from production, so that cuts the costs. But the other thing I'll say is, unfortunately, you kind of have to build it anyway, because let's say you're not using Datadiff or Datafold and CI, you probably still want to run DBT tests, and you probably still want to run validation on top of that. And shipping something without building it in CI, to me, seems very scary. So, kind of worth it. And people kind of do it in development anyway, so adding just another run in CI is kind of incremental.
Let's give a round of applause for that. Thank you so much. Let's give a round of applause, everyone.
Okay. Hello, everyone. My name is Christian. I'm a senior data engineer at Benchsci. And today, I'm going to tell you a story about building a car while you're driving. Some of you probably recognize this phrase. This is a famous phrase from Agile methodology, right? And so I've worked in BI, in analytics. Everybody, let's do a show of hands. Who's doing BI, like just business intelligence, analytics kind of stuff? Yes. Is anybody shipping data as a product? Like that's what you're selling? Okay, so thanks. Yeah, I'm in the second camp as well. I'll ask you more questions later. So we kind of have this, you've got a customer that needs a data set, or you got to get something on the website. So we have this very intense work cycle, and it evolves as we develop relationships with the farm companies we work with. I'll tell you more about that in a bit. But that's where the title comes from. It also comes from the fact that when Lindsay asked me what my talk title was, I wasn't sure what I was going to talk about. So I just said something incredibly good. Okay, so this is a little bit about me. That's a picture of corn, not a headshot. But my background is like a farming town. I live in the city, but my first jobs as an introverted person, like probably many of us are, was out working in fields and just doing agricultural stuff. I liked it by myself, lots of time to think. And then when I was doing more thinking at various universities, I did a PhD in neuroscience for some reason. Sounds cool. When I was at Stanford, all the tech people, and I was still just getting into tech at the time, were like, wow, he's an academic, he's like a monk, and they would invite me to their fancy meetups like this and give me pizza in my shabby clothes. So it was great. Then this company in Toronto called Top Hat took a chance on me as somebody with very little actual real engineering experience, and I'm very grateful for that. I was there. I became eventually a sort of full stack there. They eventually became their first data engineer and worked in BI a lot of use. We were on Redshift, Airflow. We were just starting to use DBT, which was a welcome addition to the stack when I was leaving. And I discovered this company in Toronto where I still work called Benchsci, which is actually a great mix of the science stuff and the coding. What we do is essentially we're like a search engine for preclinical research. So we read a lot of papers, lots of NLP funds, and essentially create this search experience that allows people to find their experiments better and develop novel hypotheses for biology. So it's a really cool mission. I do genuinely like working it. Well, this is not. I'm not using the company letterhead or anything, so I'm not like trying to super hype that shit. But anyway, I want to get to know the people out here a little bit. Show of hands, just with your tech stack. Is anybody who's on Snowflake? Hi. Who's using BigQuery? Redshift. Athena. I always want to be okay. Cool. Anybody using graphs? Neo4j Enterprise. All right. What about a tiger graph? I've always wanted to be a tiger graph user. Their blog posts are rabid against Neo4j. You hate those guys. Anyway, so we do a little bit of that now because of the bio. That's all I'm saying. Anyway, so great. Broadly, what the company does is we read all these publications. I didn't make this. Somebody did. I stole this from marketing. So we take all these publications, these bioinformatics databases, and some vendor information as well, CAPs, like things you can buy or run your service, and we mush it together with NLP, and then that goes to the end user. So it goes into the search indexes, which is like a mix of Elasticsearch and Postgres these days. And this is where I live. I'm helping make the pipelines and kind of cobble this stuff together. So we are like medium data, nothing like the scale that you just heard about. Our data sets are not that big. So it's kind of a different, it's a bit of a different thing. The thing that's changing constantly though is the code. So like under the hood, we're changing stuff a lot, like week over week. It's not like kind of slow modeling changes where you're putting some thought into the best way to model stuff. We're changing like the heuristics that run stuff and always trying to increase it. So it's fast. Which I like, because you can probably tell from my incredibly jittery behavior. But some people aren't here. Anyway, so I'm going to tell you a story, not really moral, but it's kind of a story called The Time We Accidentally Built DBT. Without really trying to. So I want to go over some like fun first principles first. Have you ever done this in Python? Anybody put your hand up if you've done this in Python? Yeah, okay. So you have this list of things it will tell you that are good idioms. And I don't know, attribution unknown. There's a reference to EO. They're awesome, of course. I don't maybe do that, I don't know. But I highlighted, both of the ones I like, agree to disagree. I like why tables, nested structures, but I use BigQuery all the time. That's what they tell you. But I think these are good things. And these are some things that'll come up. I'm not going to go over them, but you can import this and read them yourself. And here's some that I like as well, just at the top of the things that we're kind of shooting for. One of my mentors imparted a lot of these things to me as I was learning to be a better engineer. Still am, of course. Damp is better than dry. You know what damp means versus dry? Descriptive and meaningful phrases. So like especially in your tests. I love tests, new tests. Don't try to make it automated, just explicitly write it out. Your output data, your product, it's not your code, it's not the input data, it's what's coming out of there. And this is the combination of these two things is what makes the thing that you make. And so like, what we do at Benchsci, because our data's not that big, is we just rebuild everything from scratch every time. Right? There was a lot of work when we were smaller to try to cache and incrementally add stuff. But we realized that if we took performance seriously, we could be in a situation where we could just change anything in the stack, run it, see what happens. And that worked really well for a while when the scope of our product was smaller. It's not going that great, to be honest, right now. Like the stack takes quite a while to run. So we have to start investing in it. It worked well for a few minutes and helped us. So it's not. Anyway, storage is cheaper than compute. That's why everybody likes this, but it's easy to forget in terms of what your composable units of your code is. So of your data products. So we kind of think about it like the table I'm materializing is the thing that I'm offering to the rest of the system. I'm not offering the code that generated it. You could make it by hand. It kind of doesn't matter. You can just store things for economics. The mutables that are immutable, we build it from scratch. We don't edit after it's made, and that lets us version for free and stuff like that. And I love SQL. It's hard. It's a little, some say it's Python, but some people don't know this. SQL is storing complete, right? So you can't theoretically do anything you can do. You can't import beautiful soup in it or anything like that. But you can do pretty much anything that you want. It is a very powerful language. And I don't think it gets, particularly since it's kind of a gold standard for data stuff, I don't think we give it enough credit. This last one, we're probably supposed to do this, but I can think of some arguments where it's nice to have the people on your team get a chance to work on their own tooling. It develops your skills, and then they use those skills for real business problems. So I think this is more of a balancing act. Anyway, so we use BigQuery, and we know most of us probably know why it's good. We don't need to get into that. But here's the thing. Coding best practice. You've heard this before. Is anybody unit testing their SQL? Okay, cool, very cool. All right, so yeah, this is the problem, right? I can write big transforms in BigQuery that would handle the workloads that I was trying to do, and they would, at the time of the company, take things we were doing in Spark or Downflow and make them run a lot faster, right? And it was a lot easier. You couldn't write unit tests for SQL, and you'll see this in Docker and things like that. So we said that can't be, right? We didn't know if something could do that. We certainly didn't want to start doing ORM stuff and you unit test your SQL indirectly using Django or whatever. But like, how am I going to set up this data and easily do that? And somebody I worked with figured out, this wasn't me, somebody I worked with figured out, we said, we need to solve this problem. We're relying on the SQL. We only had a couple of queries, like probably like 5. It was really not a complicated system. We wanted those unit tests. And we realized you can set up your data in advance, right? So if you write a piece of code that creates this common table expression, it puts the data in there into memory, so it's not gigantic, and then you can just, run this. And so we have this little system where you say, okay, this is my test data, and I'm gonna, here's the query I'm gonna run, and I'm gonna, in the input, say, okay, my table, I'm gonna append a CTE at the top, like, essentially this writes this string. Okay, now I can execute this as, against arbitrary SQL instance. In our case, we were setting it to BigQuery, even though it's not hermetically sealed. But guess what? If you run CI, you're probably using time caching and testing framework. It's doing a lot of internet stuff behind the scenes. But anyway, the principle is it. So that worked. And that was pretty cool. So we're like, okay, we can unit test SQL. We're going to just keep using SQL and BigQuery as much as we can. But we realized, there was problems where, as I had more, we were writing more and more queries, and we realized that I'm defining the shape of my data in my test string. So if the upstream query changes, or like its output, then my test data is no longer out. So that's not good. And so we started defining these instances of tables. And so this is still just in the service of testing. We don't really know where we're going. And I'm just going to say, okay, this is my BigQuery table, table A, table B, and I'm going to say, oh, you've got table B, you're dependent on table A. And so I can kind of know the schema fields, and I can now write tests like this. Okay, here's my mocked out test data, use the same schema as source A, as table A, here's some fake rows, and then you can run the same kind of thing. Test table A, here's the test table, oh, this should say test table B. I wrote this slide in haste. Anyway, so this should say table B, and we can assert expected results. And that works really well. So we're adding queries, and now we're getting sick of writing like whatever we were doing to run the queries individually. And at the same time, we kind of realized, we introduced these things, and we kind of realized, oh, my box moved. The box is down here. We're just trying to go back. We kind of realized, oh wait, now we have like a dependency tree for every table that we want to build, and I know what the DAG is. And then it was like in a couple of, I think it was like a day of single developer investment, we wrote this build command that said, okay, you want to build B, here's the data set that it's going to get built in, here's the project, and it just, uses network X behind the scenes to come up with, the layers in the query plan according to what can be parallelized, and it just executes it. And that's it. So we call this BigQuery help tool now. If people like this that are interested in using it, it's not open source, we use a mono repo, so it's not trivial to do that, but come talk to me afterwards if this is something you would like to use. But this is also a bit of a story of like taking some first principles, specifically the unit testing. We need unit tests for our SQL, and really sort of investing some time because investing some time in the unit tests is finding a really neat side benefit. And I'm not sure how often this is going to repeat. We tried to get fancier after that, like smart rebuilding, okay, now that I have this query plan, and I know there's SQL, I'm going to only rebuild it. Like DBT does this. It's a cool feature. And we used it in production for a while, and we stopped because it was getting too complicated. Like, what's the right rule set? And just forget, just load from scratch every time. So we went a little too far. And we also wound up with situations where we're not using just DQ, right? Like, we're doing whatever we can to get value from the data we have. So we're running inference jobs on Datafold, or maybe, we're doing all sorts of stuff. The execution method can start to vary for what these things are. So that, maybe if we were using only DQ, it would be viable, but it stops being viable. Too fancy. So I'm going to do a time check now, since I ramble. I'm done, right?
Well, do you have more?
If you have more.
I have we can do a time check for questions, and I can give like a sneak preview of the next thing. Maybe I'll come back in 6 months if I still have time. Okay. Okay, so we'll go on to the next thing. So, and we can chat after the stuff if people want to keep chatting. So like, we keep growing, there's like 40 people in the whole company when I started, now 400. Again, not the scale, this isn't Lyft or Fair or something like that. We're still hoping to get there, but we're not there. And we start having more stuff in the stack, and the clients start to want different stuff. So we work with big pharma. I don't remember which ones I'm allowed to disclose. Go to our website, it will tell you the ones that are public knowledge. Anyway, so initially we kind of got this situation where we've got these data sets that we're creating, and the different documents, bioinformatics DBs, better catalog, stuff like that. And they go, this is a gross oversimplification of how it works. But this starts to get complicated as we have all these different sources of kind of the same thing. And we start to realize, and these boxes might be composed of it goes to Dataflow, BigQuery build tool, back to Dataflow, things like that. And we were kind of realizing, okay, we need to just say, all these things get turned into this same structured object, right? Like keep it simple, simple instead of complex, complex instead of complicated. So it's still complicated to generate these, but by the time the downstream consumer is, everything is the same shape, shares the same schema, and I can start adding rows to this same artifact that this one's consuming, and it doesn't really matter to it, and everything just works. So now we start to think about, back to what I was talking about at the start, we're creating these tables, we're creating these document artifacts, and it's why can't I just say, I want this data set, I want the NLP data set system, figure out, based on what you know on this dependency tree, what do you have to run, what version of it you might want. Maybe I want one with these articles and not something else, maybe there's internal client docs. But kind of this should feel more like I import a library, I don't need to know all its dependencies, but I might need to pin a version, I might need to do something like that. And this is due to the complexity of working with all these clients and different needs, keeping the stack as similar as possible, while treating it, again, in a very traditional software way. So that's I don't know if this is going to work. Our data delivery team is trying this. It was an idea we had a year ago. Maybe I'll come back and tell you it did work. Maybe I will come back and tell you we should have gone with a vendor. We'll see. And that's it.
Any questions from the audience? Yeah?
Thank you. Instead of writing unit tests for the scale, have you considered integration tests where you, for example, actually spin up containers with the actual database and running your queries against the actual database?
Yes. Unit tests are, in my view, necessary but not sufficient. Right? We need to still form the test pyramid. Unit tests, we're essentially just trying to move as much testing as upstream as possible. Do we still need, we still do integration tests, we still do a daily run of the whole code base. The unit tests allow us to change faster, but they are not sufficient for catching errors that you can only see through the interaction variance tests. So we do indeed do that. We run various pipeline steps comprised of many queries, on CI. It's getting kind of long these days, we're there. But yes, we also do that, for sure. It's important. It's just about minimizing, right?
One over here.
So the question is, do we see the maintenance overhead of the tool internally? And do we look at that and say we should have gone with the thing? So this is kind of the interesting thing. I don't think there's any off-the-shelf tools like that or otherwise that let you do unit testing. This is the basis of the way we're thinking about this problem. I want to materialize these things. DBT, you're going to have to forgive me, but I think the composable unit is still the SQL, and you're composing these queries, and they're these very large queries that you're using your models, and this is really good. We use DBT on top of that in our BI department. They kind of asked, oh, you're developing your own in-house tool for this, should we use it? And I said, no, you should use something that's got the right, you're the target audience for this product. It's a good product, you should use it. So I don't think this is a tool for all purposes. If you're already on DBT, you're probably fine, right? But what we were trying to do is, because storage is cheaper than compute, we wanted to reuse the materialized tables instead of the code, right? And so when you do that, especially if you use like sparse wide tables, our operating cost of running this BQ stuff constantly is very low. Like it's very good. So it's optimized for a particular way that we think about it. I want to address, when you make a decision to build your own tool, your director or whoever it is always going to ask you that question, and it's a really good question. And they'll often tell you, okay, but like that's like running your own business for doing that. And well, have you generally, even for tech companies, most of the budget for those businesses is like marketing and other stuff, right? When you're just building the code, it can be expensive if you let it get complicated. We did a bit, right, with the dynamic stuff that we had at the end. But it's depending on the scope of the thing, and this kind of comes from my agricultural background. Am I going to drive, an hour to the store and try to figure out and find a tool to like do this one weird job that all I have because of my weird equipment? Or am I just going to bend a rod on the device and like put it in the thing and it works really well for that one thing that it's doing? And I think for us, that's what this was here. But I think it's like a little more versatile than, just like a bent rod to help, put a, anyway, you know what I mean. So I think it's somewhere in the middle, right? Like this isn't necessarily something everyone would want, but I think if you're starting a greenfield project with, BigQuery, it's very easy. It's optimized specifically for how like BigQuery strengths as well. Whereas other frameworks that are trying to run everywhere, if you work with Django, it gets a little weird sometimes, right? Because it's trying to accommodate all these different things. There's a complexity cost to that as well. That was a long answer to a great question.
Can you hear me? Hi. Have you ever experimented with like a query front-end analyzer like Calcite to extract like the invariance from your SQL? Just feed it through a fuzzer. Now that fuzzers have the golden age with large language models, just generate your data set on the fly and just save that.
We have not.
Calcite plus Faker, Ruby or whatever, you get random person's data and then filter the space based on the where clauses to be like, oh, only names with A's or B's.
Yeah, for sure. And like that, I used to, we messed with that a little bit in a previous, when I was actually testing like endpoints across services. I'm like, I just need to know that this is going to work well, and you can use Faker to generate plausible data and make sure it doesn't explode your stuff. It causes errors of production. So we don't do that, but what we do in other testing environments is we actually just randomly sample and then just send random but plausible data. So it's not quite Faker, but we do essentially like we just run the stack end to end on little slivers like random publications and things like that and see how it's performing. So that's not exactly what you're asking though, but it's a little more targeted on the variation that we're expecting to have, rather than being like literally, for our stuff, like what's the difference whether the author name on the paper is ABCD versus a real person's name? Like it doesn't really matter.
All right. Thank you so much, Christian. Can we get a round of applause for Christian?
All right, hello. Can you hear me? We're in the back? Yes? Okay. Hi, everyone. Thanks for coming out and staying through all these presentations. I'm Guardia, Director of Analytics at Benchsci, and with me is Karin Martin. manager of analytics. And Karin, take it away.
All right, so we're going to start off by giving a bit of context here first. Judging by the name of the company, we are not kind of a data company. Can you hear me? Okay, thank you. Okay, so VetSource started about 15 years ago, and you can kind of think of it as Shopify, but for pet products and pharmaceuticals. So we're a B2B2C business where we basically build up a website for individual practices and allow them to work with their clients and their pet owners to buy and purchase products. And then we manage the website all the way through to the fulfillment side of things. So we do work with a lot of data. We're capturing data from a Google Analytics perspective on how people are interacting with the website, all the way through to the fulfillment side of things. Then about 4 years ago, VetSource acquired a company called VetSuccess. And VetSuccess is a data as a service company. So what makes the vet industry unique to other kind of medical or pharmaceutical industries is that all of their data is not normalized. When you think about going to the dentist or any Canadian medical healthcare, in their systems, an X-ray or any kind of service would be coded the same way. But the same's not true in the vet industry. So in any given practice, you can have the same item coded completely separately. And this makes it really hard for practices and people who own several groups of practices to understand their business. So VetSuccess made a company out of extracting all of this data from vet clinics, normalizing it, and creating data and insights. And at the same time, they also acquired a company called Vet2Pet, which again is a client engagement tool, and it allows veterinarian clinics to engage directly with their clients. So it's things like booking, sending reminders, there's chats available to engage directly with the client. And about 2.5 years ago, I would say, after this acquisition, we embarked on a big journey to modernize our data stack with the help of Brooklyn Data Co. And so.
So the name of our talk, what we didn't actually read out, it's the elusive quest for the single source of truth. So this is all about how we took all 3 of these companies and all of their data and tried to put it all together into one single source of truth. This is a phrase that I'm sure all of you have heard, and some of you might try it. So our goals were to integrate data from all 3 companies and create the largest data set of normalized data in the vet industry, retire old technology, and finally create this single source of truth that everyone could look at and agree on what was happening across the business. Just to give you a bit of perspective on the size of this endeavor, this involved 20 analysts spanning 4 teams and has data from over 50 unique sources databases. We have a bunch of internal users, over 150, and over 1,000 external users. We use DBT, so we've got around well over 1,000 models, and data from 1,000 clinics, which is about 25% of the North American market.
All right, so I joined VetSource right about when this data modernization initiative was beginning, and I spent the first little while at the job kind of speaking to everyone and trying to understand what they were trying to get out of this big project. And the thing I kept hearing over and over and over again is we want the same number all the time. I go to marketing, they tell me we've got 6,000 clinics, it goes to someone else, the number's different, revenue is different, we just need to agree on something. And so this is kind of the source of truth that I think when people hear that term, they associate this with one number all the time, no matter who you ask. And as people who are familiar with data, I think we can all kind of understand why this mentality or this concept of source of truth is beneficial. Our data teams spend a non-trivial amount of time being asked, why are these 2 numbers different? Help us understand them. If we did and could establish this, we're saving time, money, resources. People will always know where to go, and it just frees up a lot of analyst time. But the question is really whether or not this is realistic. So this is kind of a simplified view of our data stack and where we're at right now. So you can see we've got still some separate pieces over here of that success and that source, but fundamentally we're taking all of the different data pieces in to our kind of source databases, and once they're all here, we're taking exact replicas. Then we're doing our transformation step and creating this analytics production database that we are saying is our source of truth. And in this view, when we're only talking about strictly just the data teams, everyone is accessing data through Looker, whether it be our internal customers or external customers. We're all aligned and everything's great. The problem is that we are a business, and there was a large amount of infrastructure built up before this project started. Everything in this system is dynamic, things are moving, there's feedback loops. We still, looking at this diagram, as you can see, have 3 different versions of Salesforce, and that adds a significant challenge. So the tools that we've got in place can really help us technically to solve this problem. We can make copies of it, we understand the timing, but what it can't help with is the fact that we also have people. The team we work with is about 600 people, and it's not realistic, nor should it really be the expectation for everyone to always be looking at Looker. We are going to continue to have people within Salesforce, and we don't want to stop that. So taking all of this into account, it really opens up the question of, is the source of truth the same number all the time realistic?
So let's walk through one example. Let's try to find a veterinary practice. These are our main clients. The first place you might be tempted to start when you're looking for a source of truth is something that is grounded in reality, right? So in this case, we're looking at an industry standard. So maybe the industry has to find what a clinic is, and we can use that. This is the actual picture from the body that tries to make this, so you can get a sense of how old these standards are. And this is the animal health industry number identifier, which somehow is AHN. The problem is that they're trying to solve something different than we're trying to solve. For them, it's about, they are interested in the ownership of vet clinics. So every time a vet clinic changes hands, gets bought from one person to another, it gets a new number. And this is like more related to tax information because they felt that was like a better grounding for the source of truth. The problem is, from a business perspective, this is kind of nonsense, right? Like this clinic, just because it got bought, and it doesn't mean that it fundamentally changed, it's still the same building, it's still like buys products from us, right? All that same stuff, like nothing has changed. So we wanted to look for something else. Another thing that we have that is also like a sort of grounded truth is the point of sale machine, which in this case is the practice information management software, right? So this is the server, because a lot of these are still on-premise servers, that live in the clinic that store all the information of all the patients and all the clients and doctors and products, right? Everything that they sell. And then this is great because then you can connect to it and you can say, okay, you have transactions today, you're an active vet clinic. Woohoo, right? We did it. The problem is, there's a bunch of problems with that, but one of them is that, for example, a bunch of practices will share servers, right? So you connect to one server, and maybe it's not one, maybe it's 2, or maybe it's 5, or maybe you're connecting to a cloud server, and is no longer geographically bound by anything, and it's actually 100. So it actually can get quite difficult to try to find any grounding for like the thing that you were trying to count, right? Like you're trying to count a thing, and then you're trying to use the most reliable signal you can, and sometimes that is difficult. So what if we try something else? What if we allow a clinic to be defined by anyone typing anything into one of our 3 instances of Salesforce? This is the wrong answer, because this will never, ever yield anything, and other than madness for everyone involved. So we need to do something a bit better. We have to think a bit outside the box. So part of this is thinking about what it is, this question of the same question should always be the same answer. I think fundamentally, this is part of the misconception. So when someone asks you how many customers you have, it depends who they are, right? If they're marketing, if they're they might be interested in how many customers you have like contactable information for, how many customers have subscribed to marketing services. If it's sales, they might want to know how many paying customers you have. If it's finance, they might want to know how many customers we're paying to, right? Because we sell proceeds back to them. If you are, there's a million different use cases, right? If you're the customer success team, you might have a different number. So it really, this idea that there's like one number that is the one number that you're going to get starts becoming pretty complicated because the same question doesn't always mean the same thing. Okay, so what are we doing about it? We have all of these different lists of practices and they're all floating everywhere and we have to do something with it. So there's all of these like wonderful technical methods that we can use, right? So we can use like Elasticsearch, fuzzy matching, like match all these clinic lists, and come up and make common like crosswalks of all the tables defined in all the different places. We can also use human intervention, right? We can have people like looking at websites and like on the onboarding process, potentially calling the clinic whenever they're in contact with it, like a sales rep. And generally defining as few useful ways of counting things as possible, right? So really narrowing down what is like the minimum number of definitions for like any given thing that we're going to need. But the real answer is meetings, right? It's talking to the users, talking to the people. Why do we need all these definitions? Why does marketing need a different number? And like really trying to like understand what they need and like solve their problems. I think this text is pretty small, but the text says business problems require business solutions. Because at the end of the day, you have to talk to your users and like actually figure out like what it is, right? Like no amount of like fancy data tools, no amount of like fuzzy matches really going to solve these problems. You have to like, to be a business, to help the business do good things with the data, to have it be useful, you need to understand what it is that you're trying to achieve.
Yeah, so I think what we're trying to get at here is essentially, it's very easy to think in a vacuum. As probably technical people, you can think about how you could piece all of these different pieces together and have one answer. But it's kind of important to challenge that thinking and encourage people to accept that maybe there should be more than one answer. And if you can take all the different building blocks and put them in a common place, you can make sure that every piece of information you're delivering is referenced from the same place, and so you're getting consistency that way, but encouraging people to accept that sometimes the answer is different. So that's it.
We have time for questions? Yeah. If anyone has any questions, we can do two.
One, you have the best visuals for the slides. I think you teased that at the very end. What's the cheat code of actually informing or educating your business stakeholders on assessing that kind of truth, that is true?
Yeah, I mean, it's having a good relationship with them. It's talking to them. It's getting in their shoes, right? It's not trying to come from a place of my database says this, therefore it is right? It's like what is useful, what is true, right? Like maybe not the same thing. We're a business, so generally not useful, right? Like that kind of thing. And you know, there's a bunch of sort of similar concepts here, like trust is very easy to lose. This was mentioned in the first talk, right? Where like if the numbers are very slightly different, but they're slightly more correct, that's probably not worth it, right? Like it's probably like a small variation in the direction of correctness might actually be like a big problem in terms of like, do people trust it and then use it?
One question.
Thanks. I'm curious in terms of, say, you have these multiple truths. I don't know how much you've developed in terms of like documentation, and obviously no one really likes documentation, but I can imagine it'd be difficult if maybe CEO or someone wants to understand these different definitions, and also for data analysts to understand what the marketing definition is, what the finance definition is. So have you thought about that and maybe figured out some kind of useful practices that work for you?
Yeah, documentation is kind of no one wants to hear it, but unfortunately in this case, that is kind of what we're depending on. So we've got documentation built into the database and examples kind of built out depending based on the use case. So that's kind of the approach we've taken so far. And given that we do kind of interface and we are working with 3 different Salesforce instances, that kind of also opens up the opportunity for us to reference these different data points as we do define these different things. So we're working with those teams as well to do that.
Last question here.
It's actually kind of similar to that previous question. So where exactly do you land that documentation? Like, at least in my previous business, which was like an e-commerce business, we wrote quite a lot of documentation, and then no one read any of the documentation, so it was kind of useless. So I was just curious.
So you're a man after my own heart. I have been very skeptical of documentation to all of my team's chagrins, but DBT is great. So DBT actually lets you put it in somewhere, and we actually share. Part of the business is giving our clients their data back, right? So we'll like connect to a point of sale machine and normalize it, and then we'll like give it back to the client. And we put the same documentation in there that we have internally, so it's actually exercised and used, and then people get to see it, and then the client will say, this doesn't make any sense. It's like, oh right, someone wrote it like late one night, and then we'll go and fix it. And like documentation that actually gets referenced to more of our clients is much, much better than documentation that we build for ourselves, right? So there's you have your own dog food, right? There's like all of these things that can help you exercise documentation so it's not stale and useless.
Awesome. Thank you so much, Will and Karin. So that wraps up our speaker talks. I'm going to pull 180 and actually have it on the panel. So if we can get Scott and Gleb up here, we're just going to set up the panel quickly. Thanks, everybody. Just give us a second.
Is it BYOC?
It is. It's bring your own chair.
We need to sit here. Order.
So formal. We have one more after that.
Further, so we're not.
Oh, so we're on the way. We're all heads. It might be overkill. There we go. Cover. Okay. There's a mic here, and then we'll use this one, I guess. You guys can hear okay in the back?
Hello? Okay, we're almost there. This is pretty jam-packed, but I promise this is going to be really great. So, I'm here with Gleb, Scott, Lindsay. We've done intros for everyone. Just a quick intro for Lindsay, because she didn't really intro herself. She's my co-organizer for this meetup, did a fantastic job. Let's actually give it up for Lindsay. For those of you who know what Dakota is, Lindsay's their head of data. Dakota's data workspace, catalog, a lot of things. Really interesting company with a big, strong presence. So go check them out. Cool. Okay, so the whole idea behind this talk is where we are in data today and where are we going. Okay, and this is brought about by the fact that we're seeing massive shifts in the way that software engineering is done and the way that businesses are improving their decision making as a result of this wave of generative AI and other types of advancements. So I wanted to sort of get feedback from vendors, from people who run consultancies, from practitioners on where they think the industry is going. Cool. So just to start off, since Gleb, we've seen a lot of you, and Lindsay, we've seen a lot of you. Scott, I'm going to start with you.
Okay.
This is a softball. I'm just curious. I want you to tell people a little bit about Brooklyn Data. Specifically, Brooklyn Data is probably one of the premier data consultancies working in the modern data stack, and you've had exposure to a really wide variety of industries and sectors, like many, many companies. So how have you sort of taken that diverse experience and used that to basically formulate your practice of data engineering and analytics engineering?
That's a great question. I mean, so maybe just step back. My background is, before starting Brooklyn Data, I led the data team at a startup called Casper. We sell mattresses, and we were in Canada. I don't know if we're still in Canada now. It was a really interesting time. This was early in the modern data stack. We didn't even call it modern data stack. We were one of the very first users of DBT. The first consulting client was Fishdown Analytics. And we were kind of like, I would say, figuring it out as we went along. And if someone had asked me at the time, it's like, what's the best tool or the best way to do this? And I would tell them the way we're doing it and say, like, that's the way I know. But the cool thing about a consulting firm is like, and this is kind of our unfair advantage, is we have 60 concurrent clients in different industries and different sizes, and basically every single client is an opportunity to try a different approach, question your assumptions, and essentially data points to inform you the best way to do things, the best tool for each situation. And the wild thing is, and I'm sure you all know this, that the database is changing so quickly that the answer now is not the same as 6 months ago or a year before. You look at those kind of the kind of that mad landscape that FirstMark puts out, and there's new logos every year, and it's I mean, we even struggle to keep track of it. I can't even imagine what kind of a company that just operates one stack does. And so, I mean, what we've essentially been able to do is take these tools and push them to their limits and see where they bring. We're implementing Snowflake and DBT and Fivetran and Sigma tools like that for startups, but also for large public hospitals. And everywhere between, you can kind of see where things break down. And so on our side, what we've essentially done is we've created almost like playbooks and rules of thumb and internal kind of enablement, just so we know, like, hey, at what point does this tool break? And constantly revisiting that. So I think there's no magic answer that you almost have to constantly be evaluating all the tools, stress testing them, pushing to the limits from complexity, compliance, size, to really understand, and even cost, because price is changing all the time. And it's like a full-time job at Brooklyn Data, just keeping track of the trends in the industry.
Yeah, for sure. I mean, as Scott said, there's been an explosion of data companies and startups in the last couple of years. Zero interest rate phenomenon, I don't know. There seems to be a tool for everything now. So let me hand it over to Gleb. I'm curious. How do you, there's so many spikes in the hype cycle. There's, observability was really hot a few years ago. Then it was catalogs. Now it's semantic layer, data contracts. So from your perspective as a vendor, how do you, and also more importantly, how do practitioners make sense of these different hype cycles and discern the sort of noise from the actual valuable new pieces of the stack?
That's a great question, Jonathan. I think hype cycles and in general the proliferation of tools in data is great, and I'm saying not because I'm one of them, but because it always bugged me as a data engineer that my workflow was so manual and so tool deprived compared to my peers in software engineering. And I think it still is. I think we're barely scratching the surface, even with great platforms like DBT, working on top of great analytical warehouses. I still think that we're barely touching what's possible to really support data engineers, UX engineers in their workflows. But I think the hype cycles are there because when certain leaps happen and people explore ideas, then some of these ideas are getting a lot of marketing behind them, and so sometimes ideas are pushed really, really hard on us. And I think there's some probably noise in it, but also I think that in general this creates very healthy momentum behind improving the quality of life and tooling for very, very important profession of people who are working on preparing data to make it useful. So I'm all for more tools in this space.
So just to double click on that, there are the breadth of the tool set is expanding, which is really great. But there also seems to be oversaturation within specific categories. So just as an example, observability. There must be 10 to 20 different startups working on observability, and every other week I still get a LinkedIn message from somebody who is thinking about data quality, and they're want to ideate a little bit. So why are there so many of these observability companies that are over data quality companies? And how do you sort of sort through that noise?
Well, obviously you choose Datafold, but we're not no, you don't choose Datafold from observability, not observability company. I think the answer is that the problem of data quality is really big. And if you think about software quality, well, how many companies contribute to that problem one way or the other, right? You have GitHub, and you have Datadog, and you have Terraform, not to mention hundreds of other companies that, for example, make your Kubernetes configs not blow up your clusters. And I think the fact that we have just 10 or 20 companies working in this space, maybe it's oversaturated for a very particular problem like monitoring tables in production, but still I think we barely scratched the solution for how to make data reliable. And I think the other good thing is that there's a lot of competition, so we're seeing a lot of teams that are working in these areas that are hyper-competitive ship a lot, and I kind of see the gaps between those who do ship a lot and those who don't. And I'm a capitalist, and so I think like this is good for the industry.
That's a dirty word in Canada.
Sorry. So yeah, well, I think the best tools will eventually win, and this will be the great thing for everyone. And then those who don't win probably will become part of some other big platforms and will add value there.
Okay, so I'm going to pick on you one more time. So you guys stand alone in a way in terms of focusing on prevention. I'm not sure how many people here know a lot about Datafold, but they really are focused on that CI part and the IDE, so preventing bad data from getting in. And like all that 25 companies I mentioned, they're almost all on this sort of continuous data quality monitoring once the damage is already done. So why, I'm curious, why did you choose that approach? And furthermore, why haven't other companies sort of started to encroach on that territory, or maybe they already have?
Yeah, I think that has to do with, again, the problem is big, and just like in software, you do need monitoring for systems in production, right? You have to have systems like New Relic or Datadog to know what's happening with your systems out there, what's the real world experience of the users. And so data observability tools, they almost try to play the same playbook and mimic that and solve that for data teams. I think it's a very valid problem. The reason why I chose to focus on a different problem is that I saw that the most effective way to address a lot of the issues are actually within the workflow before the code is actually deployed, because that's when we are writing it. That's where we're introducing regressions or new features. And so the more you can do in the workflow, the better the outcome for the team, because while one is preventative, you prevent fires as opposed to detect them. Two, I think that, again, the workflow of data engineer is quite hard. We do a lot of context switching constantly. We get pulled in different directions by stakeholders. It's hard enough, so the more support you can do while people are developing code and deploying code and reviewing code, the more effective it is. I think my personal insight comes from Lyft, as you've heard. I had some horror stories. So the story behind Datafold is actually me pushing a hotfix into an Airflow job at 3 a.m. in the morning, and was actually in the dimension rights table that I talked about today. So 3-line SQL filter, and I got a code review, I tested it, everything went well, and then, as you can see coming, so next morning I come to work, and everything seems normal except for all dashboards kind of look like this. And the craziest thing is not that I blew up the most important table in the company with a 3-line SQL hotfix. The craziest thing is that it took us 6 hours in the war room with me and like 5 other engineers to actually be able to pinpoint all the anomalies that we're seeing in the data to change what I made. So it's very unobvious. And so the more you can do within a developer cycle, I think the better is the outcome for an engineer and the business. Sorry, that was a long answer, but.
So, it's often said that business problems can be categorized as people, process, or technology problems. We talked about how there are so many SaaS tools available now to solve every single technical problem you might ever have. So I'm curious, and I'll give this to you, Lindsay. what are some of the prevalent social problems, with people and processes that you've seen in the various companies where you've held senior analytics roles?
Yeah. So I'm transitioning roles right now. I'll be starting this code on Monday, actually. But I was previously at Benchsci previous, and then Maple just previous to this. And I led data teams there. And one of my roles, obviously, was to figure out how do we make the team more efficient? How do we do more with less in the environment that we're in right now? And with all these new tools coming out, every tool seems to be adding an AI component. It seems to be the promise of, it's going to fix all of our problems. And it's just, I don't really think that's the case. I think where we will see a lot more efficiency is kind of taking a step back and even going back to like project management best principles and thinking about what are your standard operating procedures as a team. And a lot of startups work in very scrappy ways. It's like maybe you're doing something for the first time and nobody really writes down like this is how I did my work in step by step. But I actually think kind of taking a step back, mapping out SOPs and actually figuring out like where are bottlenecks, where are inefficiencies, and how can we solve these with human problems potentially first, with human solutions, and then figuring out how tools might help out with that. It seems to me that like every time we add a new tool to the stack, you actually create more problems because then people have to figure out how to work with it, how to work together. So yeah, I think kind of just taking a step back and thinking about it from a human standpoint.
Right, yeah, so tools are a blunt instrument that you can't use to solve every social problem in your business. Scott, you work with tons of companies, you go into, you upgrade their stack, you help them with migrations, you push new technology to them. So same question to you, what are the types of social problems, human problems, processes that you either implement or encourage companies to implement when they're undergoing these transformations?
Yeah, I mean, that's a great question. So, we help companies from early C2 startups to Fortune 500 to implement the modern data stack. And for me, the modern data stack is a few things. It's the tools. It's like something like DBT, but it's also modern engineering practices. And so, what we actually do is we have to, often train our clients on how to use Git and pull requests and CI/CD and just good coding culture. I mean, for instance, like we work with clients that they might have theoretically understood what a PR review is, but that for them it's like clicking a button. Okay, cool. Someone else has to click the merge button, but really it's integrating the testing. It's integrating the review culture, and so I agree with what everyone's saying. It's like these tools are amazing and they enable us, but you've got to develop the cultural practices around it. Like DBT, for example, great tool, no rules. No frameworks. I mean, like the only rule is you can't use the file name twice. And that's really the only rule in all of DBT. And so you can do kind of brilliantly kind of complex and sophisticated models, or you can do crazy messes. And you could have Datafold, but people could ignore it and not use it. So you have to pair that adding the tool with the training. And to your point as well, like whenever I bring a tool, I always kind of think I have to probably bring another person, or at least put a person that's owning that tool to make sure we're using it. Because, we've all come to these companies before, and you have all these tools. I mean, you're probably better off having half as many tools and doing it right, and just being thoughtful. Because the tools are just frameworks or opportunities to reinforce good process and culture.
That's a good lead into the next phase of this panel, which is where we're going. And this is what everyone wants to know. Where are we going in data and tech, with recent technological innovation and all of these new tools that are coming into the foray. So I want to start with you, Gleb. So actually, let me talk about the industry first. So we're now sort of experiencing a tech downturn. Shopify, unfortunately had big Toronto presence. They let go with a sizable number of people. So sort of anyone in Shopify, we're sort of thinking about you. It's been a tough day for them. A lot of these companies that were really well funded in the last couple of years, and they were doing whatever they could for customer acquisition, are ending up in a situation where their runway is running out. They have low ARR, or don't have, and it's harder to get new customers because there's so much competition in the space. So I'm curious, what's your prognosis for, let's say, the data tech landscape? Are we going to see a lot of consolidation? Are we going to see failures, mergers, acquisitions? I'm curious where you think we're going.
Yeah, no, I think you put it really well in the sense that you'll probably see all of the above. Like, I think that there are some foundational technologies that in the modern day stack define the platforms on which we build, like warehouses, platforms like dbt, and then there are also the adjacent tools, which, for example, Datafold would be one of them, that improves the workflows of teams in one way or the other. There are also catalogs, observability tools, machine learning support tools, and BI, and all of that above. I think it's definitely a shake-up for the industry and a big stress test. Like, money is less abundant than it was before. The budgets are tighter, and I think it forces everyone to be smarter and ship faster and just be more, scrappy. For example, one of the things that we had to learn how to do much better internally at Datafold is helping data teams advocate for their budgets and for budgets for their tools. Because, in the times when money is less abundant, funding is less abundant, typically budgets kind of get consolidated somewhere at the top. And data teams are one of the first, unfortunately, odds or functions that gets those budgets really tightened up. Like marketing still has these budgets, but for data teams, it becomes harder and harder to advocate for their tools. And so we found a way to help our users articulate the value through basic automation for a lot of manual work that we found really successful. It does work for us, but I think that justifying ROI for every tool in the stack, even if your technical users and teams understand it, how do you justify that for the business is a big challenge that a lot of the players in the space will be navigating.
Right. So it's for newer entrants, it's often requires a little bit more fighting, a little bit more convincing and persuasion. But if you think about like dbt or your orchestrator or your cloud data warehouse, right? Those are sort of established, given like you're going to have them on in your data stack, and there's no question about them. So Scott, I'm wondering where do you see, in terms of current trends or future trends, do you see any other tools or categories becoming as ubiquitous, as important as those sort of core pieces of your stack in the future?
Yeah, that's a great question. I mean, maybe back to your last question, I don't think we'll see any failures of any companies. I think, we might see companies that don't get as big as they thought they would be, and they're kind of merged with a larger company or acquired. I'm thrilled to see Transform was acquired by dbt Labs, because I think they could do really special things with kind of metric flow. So I think we're just going to see this kind of phase of consolidation, these really, really great, innovative small teams joining forces with larger organizations with better cash positions, better cash flow, and building even cooler brands. I think, in terms of your question, what tools have we seen? We've seen a lot more reverse ETL recently. Orchestration is one of those tools that I'm very excited about, but it always feels kind of like 6 months away to see kind of these orchestrators breaking out. It's going to be interesting to see what kind of ChatGPT and those type of things do, but I think they're probably going to be more features on top of existing tools that just make existing tools smarter. So I don't see any huge breakout categories. I think you'll probably see just more consolidation, in like catalogs and those type of tools, either kind of bunching amongst themselves or joining a much larger company. Like, I think you're going to see companies like Snowflake and Databricks and IBM and Oracle and dbt Labs just snap up a bunch of smaller companies and add them to their stack.
Well, are you surprised that it doesn't seem like it's happened yet? Like, I mean, why hasn't Fivetran scooped up a reverse ETL? Why hasn't dbt Labs acquired some Lightdash or something? Snowflake as a war chest. I'm kind of surprised that there hasn't been more.
I think give it 12 months, 6 to 12 months.
We're at early stages.
We are early stages. People raise a lot of big rounds, and so a lot of people have a lot of runway. So I don't expect the innovation to slow down, but I think we'll just start to see consolidation. We're seeing like the first pops of the popcorn, and I think it will just like start popping a lot more probably 6 to 9 months from now.
It'd be exciting for sure. Okay, we're getting close to wrapping up here. I wanted to ask you a question, Lindsay. you mentioned ChatGPT, and so what we're seeing is a massive growth in natural language interfaces for data. So Sakota recently released their own natural language text to SQL. But there's like maybe 15 or 20 companies that I've seen that are doing text to SQL. So how do you think that natural language interfaces will shape the sort of reporting analytics BI part of the stack?
Yeah, it's going to be really interesting. As someone who had a very intense love-hate relationship with Looker, I feel like it will hopefully prevent the need to maintain these like massive Looker code bases, which just was, trying to have the dream of self-serve and then everyone coming to you every other day asking you to make them a dashboard after you put so much work into this. So that's my hope, I think, is that maybe it can replace this like self-serve analytics that we've put so much work into. And that it will hopefully get more people from non-data teams involved in the data workflow, being able to take their questions directly and actually get an answer out of the system without needing the data team, which might sound scary, but I think it will actually free us up to do more interesting things as data people.
Sounds exciting. I'll have less DMs. So we've now seen that Copilot, AutoGPT, ChatGPT, you can basically build a web app in minutes and deploy it. But I feel like there hasn't been a lot of traction in data engineering and analytics engineering, data modeling for these tools. So I'll ask all of you, but maybe starting with you, Gleb, how do you see the practice of data engineering and the practice of analytics engineering evolving in the age of AI?
Yeah, that's a great question, Jonathan. I am with Lindsay there that it'd be great to automate a lot of the self-serve business questions. I think the biggest challenge there is the disconnect between the intent of the user, understanding of the system, or the AI of the internal data model, which currently is filled by data analyst or analytics engineer. It's probably going to be the hardest to automate. So I'm actually a little bit more skeptical about the frontline application of AI, so sort of like will replace an analyst kind of AI. But I'm more bullish about empowering the actual practitioner to do their work faster, because they have all the necessary context so they can supervise the system that just automates a lot of manual tasks for them. So that's definitely a direction that we are investing a lot within improving the data engineering, analytics engineering flow. So give us a couple of months and we'll show something really cool.
I can't wait. Scott, where do you think data engineering and analytics engineering are going?
Yeah, that's a great question. So I think, simply Gleb, I think on the front side, like front end asking questions, I think what we're going to, over the next 6 to 12 months, we're going to see kind of that ChatGPT style interaction to come into like BI tools and analytics tools. But I think we're going to peak really early. Like we're going to have a burst of just like really excitement, and then it's just going to, just like almost like self-driving cars, where it's like we made this great progress, and then we realized it's going to be like another 15 years before they can actually drive themselves. So I think we're going to make a lot of progress in helping folks answer questions, but we're going to realize that there is a magical insight to how analysts can help and think through data. And then on the development side, I think we're already seeing the data side, like Copilot, other tools like that are just fantastically helpful in developing. They're just like great efficiency tools. And so you're going to see these like 10x developers that just really know they have their coding environments, not just with the different VS Code config files, but also like some sort of AI augmentation on the development process where you're just going to fly and I think you'll find. I've kind of heard people say this, and I agree with them, is that right now the difference between top engineers and kind of bottom performing engineers, there's a gap, but I think you will see that compounds, that the most highly efficient engineers will be able to produce orders of magnitude more than the lowest performing engineers.
That's going to help me a lot in my career. Cool. I think actually, I think that we can wrap it up. Thanks a lot. Let's give a round of applause for all of our. And thanks everybody for joining. I think the new Meetup for June is live. You can go to meetup.com. You can RSVP. And other than that, we're just gonna finish the rest of the alcohol and maybe hit the bar if you can beat the Leafs fan stuff.
Yes, yeah, we weren't able to get a reservation anymore because the Leafs game is taking up everything. So, but if people do want to go for drinks, I've heard there might be room at Boston Pizza. That's not too far. So, if anyone's interested in going there.
All right, yeah, thanks.
And I have so many T-shirts and stickers that I cannot take them all back to the U.S. So please take them for your friends, take them for your significant others. Thank you.
Hey, you're recording. Oh, nice. Did you turn that off?